Now, dear students, chapter number 7, System of Particle and Rotational Motion. And today we have some basic topics. Those reveal the concept of the rigid body. And the rigid body, which is made or it is a sum up of the particles, and which makes the concept of the system. And if the system is there, so there is a probably meaning of the internal forces, and as the object is moving or making the motion, there is a concept of the external forces also. Okay, so first we want to discuss the meaning of the particle. And the meaning of the particle, that object whose mass is very finite, and its internal structure can be the neglected. And in the other word, we can say that the smallest unit of a system is called the particle. So here we have mentioned the 2 or 3 points. A particle is defined as an object whose mass is very finite. Where size and internal now size and the internal structure can be the neglected. So this concept is called the particle. Now what is the mean of the system we have? Now system is a collection. System is a collection of large number of particles which may interact with each other. Now, as we are just imagining the system, so the sum of the particles, or all the particles are making the collision with each other, or they are just acting the mutual forces on each other. So these forces are known as the internal forces. In a system, all the particles are applying mutual forces on each other, which hold system together. Now, what is the concept of the external forces we have? The force which applied on the system from outside is called external force. and it causes motion. It causes motion. Now next we have the concept of the rigid body. Now what do you mean by the rigid body? So it is simply a body as we are just applying the external forces on it. So there is no possible change in the intermolecular distances. So this system is called the rigid body. So here we have the general basic define of a concept of the rigid body. The body having the definite and the unchanging shape and the intermolecular distance does not change is called the rigid body, as we are just applying the external forces on it. So this is the concept of the rigid body we have. As we are just imagining a rigid body, so what are the types of the motion can a rigid body have? So we are just discussing all the types of the motion of a rigid body one by one. So first I have taken the rigid body on an inclined plane. As I am just assuming the situation, the body is making the sliding down. So this is the rectangular box we have, okay, and it is be taken at an inclined plane, that is AC, which makes the angle theta with the surface that is called the CB. Okay, so here we are just assuming that the box is making the slide down. So whenever it's making the slide down, so all the particles those are inside the system or inside a rigid body having the same velocity, so here we are just assuming that v1 is equal to v2 is equal to that is called the Vn, and all the particle having the same concept of the velocity, okay, and all are moving with the same velocity down from the down inclined plane. So this is the type of the motion of a rigid body we have, okay. So here we can assume that it's a simply a translation motion. It is a translation motion. So here we can make the little bit adding the word, the body making slide down where v is constant or that same for all the particles, and it is pure translation motion. It is pure translation motion we have. Now the next motion of a rigid body, that on an inclined plane whenever it making the rolling down, okay. So here just I am assuming the rolling without slipping. What kind of the motion and of an object of or the rigid body have? Rolling without slipping. So it's simply a combination of the two types of the motion. First is the translation, as the whole object is moving from the down inclined plane. Translation plus if it is making the rolling, so we are just making the assumptions of rotation. So it is a type of a combination motion, as we can assume that all the particle those are lies inside the spherical or the cylindrical body having the different type of the velocity. Now the one of the particle that is available on the rim, it having its velocity that is called the v1, where the particle which is at the center of the body, so it having its own velocity that is called the v2, and the particle which is in the contact to the surface of a inclined plane, which having the name that is p3, but it having the velocity that is v3, and v3 will be equal to the 0. So all the particle having the different velocities. So here the one of the specification that different velocity of all particles In case of the rolling without slipping, that is combination of the translation plus rotational motion. So this is the one of the important that mean concept we have. Now we will talk about in the sense of a rotation. Now here we have the rotation motion, and the motion of an object about its axis. About its axis is called the rotation motion, and the axis which is called the axis of rotation. This is called the axis of rotation. Axis of rotation we have. Okay. Now this is the simplest example which I have taken, that ceiling fan is there. Ceiling fan is there. Ceiling fan is there which making the rotation about its axis of rotation. So it is an example we have. Okay. So probably here we are just assuming the object is not making the any kind of the translation motion. Now what are the motion of an object about a fixed axis, that is called the motion of an object about a axis of rotation, that is called the Potter wheels we have. Okay. Here we have the potter's wheel. Okay. And the potter wheel is making the rotation about its axis of rotation, that is a fixed axis we have. Now this axis is the fixed axis we have. So easily we can understood. Now we can assume the basic statics of a motion of a rigid body. So as a whole body is making the rotation about its fixed axis of rotation. So what are the basic assumptions we can made here? As I have pasted one of the basic diagram of a rigid body. This is the that mean diagram of a rigid body. This is the diagram of a rigid body we have, and we are just assuming the rigid body in the xy plane. This is the x-axis we have, this is the y-axis we have, and the body is making the rotation about the z-axis. Okay, so whenever we are just imagining the number of the particle inside the body, those are having the different distance from the axis of rotation. Now what is the z-axis along which the object is making the rotation? That is called the axis of rotation. Axis of rotation, dear students. Axis of rotation. Now about the axis of rotation, it making the movement or the making the motion, that means making the rotation about the axis of rotation under the influence of an external force. So here we are just assuming the number of the particles are there inside the bodies, those having the different distance from the axis of rotation. So I have taken the basic 3 points. Those are at the particular distances. Okay, one of the point which I have taken, that is called the pivot, and it is basically lies on a axis of rotation. Okay, so generally it comes in the nature that is static in the nature, and it does not forms any kind of the horizontal circle. Okay, now I have assumed the point P2 in the horizontal plane, which makes the circle of the radius, that is called the radius of the R2 in a horizontal plane, that in the xy plane, as the body is making the rotation in the 3 dimension. Okay, so the particle P2 having its own linear velocity, that is called the velocity v. Okay, so, and the whole body is making the that mean rotation about the axis of rotation with the angular velocity, that is called the omega. So easily we can say that v is having the relation with the omega, that is called the v is equal to r omega. Okay, so this is the basic concept we have. Okay, now as the particle 3 is having the different radius of the circle, that is called the r3, and it although making the that mean movement at the rim or at the circular portion with the velocity v3. Okay, so here we can assume that v3 is equal to r3 omega. Here we can assume that the velocity v2 with the concern of the radius of the r2 and the omega, that is constant. Okay, so the particle having the far distance from the axis of the rotation, it having the different velocities. So here we can assume that v3 is greater than v2 is greater than that is called the v1, and v1 is nothing but it's simply the zero, because a particle is not considering considering any kind of the horizontal circle, it is in the static manner. So this is the basic statics we can discuss as the rigid body is making the rotation about its axis of rotation. So how the particular velocities, that mean linear velocity and the angular velocity, can be act with the concern of the radius. Now in the example number rotation examples of the ceiling fan and the porter wheel, we have discussed the axis is the fix, and somehow if there is a no fixing of the axis is there. So some of the more example we have of a rigid body, so we are discussing them. Now one of the basic example we have of the spinning top. Okay, so here we are just taking a concept of the spinning top in which it is making the that mean movement, its or its axis of rotation is making the that mean movement in a horizontal plane. Okay, here we are just making that point of contact of top with the ground, as it tips O is fixed, this tip is fixed we have. Okay, and it's the axis of rotation which makes the movement inside a particular cone shape. Okay, so inside a cone shape it making the movement. Okay, so this is the particular movement of a spinning top we have, in which the axis is not fixed, axis is not fixed. Okay, the movement of the axis top the movement of the axis of the top around the vertical is termed as precision. Here I can add the word the movement of the axis of the top around the vertical termed as okay. So here we are just assuming the point of contact to the surface is a fix. Okay, so the movement of the axis of the rotation that around the vertical is termed as precision. Okay, so this is an important concept we have. Now one of the another example we have, we can assume the an oscillating table fan, in which also the axis of rotation is making the movement sidewise with the concept of the angular velocity omega, and one of the vertical axis, that is the fix, which also making the concept of the rotation is there. Okay, so this is another example we have of the fan, oscillating table fan. Now whenever the motion of a rigid body which is the pure in the nature, that is which is pure translation in the nature, so how can we discuss this one concept? So one of the moment of a body which I have taken from point A to point B. Here I have assumed that there is a no kind of the, that mean position of the body is changing during the parabolic path. So here I can assume that at all the portions the velocities of the all the particles those are inside the system can have the same velocity. Okay, so here we can assume that at the particular instant the velocity of the different particle can have the same. Here the velocity is v, it is also the v. Here we have the velocity v, it is also v. Here we have the velocity v and it is also v. Now the axis which makes an angle alpha. Okay, here I am just assuming the that with the x-axis, here the axis of the rigid body makes an angle with the horizontal, that is called the alpha 1. And here we are just also although assuming the angle of the axis with the axis, that is called the alpha 2. Here we are just also having the angle, that is alpha 3. Now during the motion, the meaning of the alpha 1 is equal to alpha 2 is equal to alpha 3. This is the same for all the point of contact, okay, during the motion. So this is the pure translation motion we have. And on the other hand, if you are just assuming translation with the rotational motion is there, so what kind of the velocities and the angle alpha, that means angle of the axis with the horizontal axis, kind of the relation, so we would, which we want to discuss here. Here I have assumed that the motion of a rigid body, which is the combination of the translatory and the rotational motion. So what can I assume here? Now the each portion having its own velocity. Now somehow the motion is starting, so initially we are just assuming that the position of an object in which the velocity is v1 and the v1. Okay, here I am just assuming the v1 and the v1. Okay, now as the body is making the somehow the rotational portion is also there with the translation, so each portion having its own different velocity. Suppose this point p2 is there, so velocity is the v2 is there. Now this point o having its velocity, that is called the v. Now the both the velocity can be differ. Okay, here we are just assuming the velocity v3 and the point o, that is called the velocity vo. Okay, now here we can assume the axis of the rigid body making the angle with the x-axis, that is called the alpha 1. Here we are just also assuming the alpha 2 is there, and here we are just also assuming the angle, that is called the alpha 3 is there. So all the time the meaning of the alpha 1, alpha 2 and alpha 3 all are different, all are different. Okay, so this is the basic assumption we have, or basic difference we have between the translatory and the rotation motion. Okay, so here we are just assuming the basic concept on behalf of the discussion. The motion of a rigid body which is not pivoted or the fixed about a point may be translatory or the combination of translatory and rotation. Okay, so this is the conclusion we have discussed here. The motion of a rigid body which is not pivoted, यानी वो किसी एक्सिस के अक्रॉस फिक्स्ड नहीं है, then it may be the translatory and the combination of the translatory and the rotation. If we are just assuming the translatory, so all the particle having the constant velocity. Now it is not a that mean translatory pure translation motion is not there, so we are just assuming the translatory which having the rotation motion is there. So we are just assuming that all the particle having the different velocities. Now the motion of a body about a fixed axis, where we are just assuming no translation motion, only the pure rotation motion is there, which is the fixed about the axis of rotation, which is fixed about the axis of rotation. So this is the simplest explanation of the all the portions we have. Okay, so first we have discussed the meaning of the particle, including the meaning of a system we have. Okay, then after internal forces, external forces, rigid body, and the types of the motion of a rigid body, including the pure translation motion, translation with the rotational motion of a body about the axis of rotation, that is the fixed, and the motion of a rigid body about the axis of rotation where the axis of rotation is not fixed. Okay, so we can make the basic that mean difference in the all the portions.